In this video, we're going to do example 3.4.2. We're asked to use a linear approximation of a function of three variables to approximate the value of the cube root of 8 plus 1, 8.1, times 0.9 squared divided by 1.2. And then we'll compare this with our calculated value. Now, in this example, neither the function nor the point of linearization are given to us, so we've got to choose those ourselves. And we are going to take a function which looks similar to the expression, so we'll let f of x, y, and z be the cube root of x times y squared over z, which I can express entirely using exponents, so x to the 1/3 y squared z to the minus 1. And we're going to take the point P, our point P of evaluation, our point ABC, as the point A, 1, 1, which is close to 8.1, 0.9, and 1.02, but is nice and easy to evaluate. So in particular, if we do f of 8, 1, 1 is going to be the cube root of 8, which is 2, times 1 squared times 1 to the minus 1, that is just 2. We need to calculate the linearization, which means we need the partial derivative. So f sub x of x, y, z, power rule is going to give me 1/3 x to the minus 2/3 y squared z to the minus 1. Evaluating it at p, so f sub x of 8, 1, 1 is 1/3 8 to the minus 2/3 times 1 squared times 1 to the minus 1. 8 to the minus 2/3 is 1/4 times 1/3, we have 1/12. F sub y of x, y, z is partial with respect to y, 2. X to the 1/3, y, z to the minus 1. F sub y at 8, 1, 1 is 2 times 8 to the 1/3 times 1 to the minus 1. 8 to the 1/3 is 2, 2 times 2 is 4, 4 times 1 is 4. F sub z of x, y, z is minus 1, x to the 1/3, y squared, z to the minus 2. Evaluated at 8, 1, 1, we get minus 8 to the 1/3 times 1 squared times 1 to the minus 2. 8 to the 1/3 is still 2, so minus 2. We need to use the linearization, and so our linearization L of x, y, and z at the point P is going to be f of 8, 1, 1 plus f sub x of 8, 1, 1 times x minus 8 plus f sub y of 8, 1, 1 times y minus 1, and finally f sub z of 8, 1, 1 times z minus 1. Here we have our values that we're going to plug in from above, so 2 plus 1/12 of x minus 8 plus 4 times y minus 1 minus 2 times z minus 1. And so the idea is that this linear function is a good approximation for this nonlinear function in points that are close to P, or at points that are close to P. So we want to evaluate or approximate f of 8.1, 0.9, and 1.02. That is approximately equal to L of 8.1, 0.9, and 1.02. Extra bracket crept in there, which, if we plug in here, is going to be 2 plus 1/2 of 8.1 minus 8 is 0.1, plus 4 times 0.9 minus 0.1 is minus 0.1. I said that wrong, but the final answer is right. Minus 2 times 1.02 minus 1, that's 0.2. And when I calculated this earlier, I got approximately 1.61. Not approximately, gave me exactly 1.61. We're asked to compare with the calculator value. So we're asked to compare with the value that our calculator gives us, which actually is still an approximation, which is, so this is the cube root of 8.1 times 0.9 squared divided by 1.02, and my calculator told me that that was about 1.59. So the linear approximation that we got is actually quite close to the calculator approximation. These are an irrational number, right? This is not the exact value. No, even if I included more digits from my calculator, that would still be an approximation, a much closer one than our linear approximation, but still our linear approximation was not too bad. In the next video, we will start talking about another way of doing approximations, and that is with differentials.